Hey guys, how's it going? So he just said I was going to say for this first slide, but XenLabs is a virtualized CS lab environment. And I want to break that down. The first thing is, what's lab? At Oberlin, in our computer science department, a lab is one of the primary components of our coursework in most of the classes. It's usually a programming assignment that you complete by yourself. An example of one would be like writing a web browser and like parts. So you like write a program that parses HTML and a program that like handles, et cetera, and so forth, right? So that's really, really good for like introductory courses. But as you get more advanced and get into like computer security or networks or operating systems, the problems become a lot more complicated involving multiple machines. And that's just not served well by that traditional model. And Iowa State, who we're working with, has encountered a similar problem, and they have a similar project called XenLabs. Ours is different, as I like to think. So maybe you're wondering why this is so important. Hands-on experience, especially in a class like this, is really important. It's a very different thing to say this is how an exploit or an attack works, and to actually perform it yourself and defend against it is a much different experience. And experience in information security is also increasingly in demand. There's an article in NPR a couple of days ago saying that the US is basically doomed because there aren't enough trained cyber warriors to defend it. Maybe a little bit extreme, but the point is there. And this kind of experience is easier to find at large research institutions, but at Oberlin, we have space and budget resources that constrain us. So our software is a solution to all these problems. We use virtualization, which maybe you're familiar with if you ever used like Parallels or VMware, something to run like Windows on your Mac to play games or use your favorite program or whatever. This is the same basic technology, but in our case, we're using it to run multiple virtual machines on a single physical box. We can run different operating systems, any flavor, Unix, Linux, Windows. We can run multiple machines, different systems, all on one machine. And these are just some examples of virtualization that maybe you've seen before. We wanted to use it because it's cost effective. If you wanted to have a dedicated security lab, for example, you need to have maybe 24 machines for a small school at Oberlin. So this is one of our actual labs. So you can replace this in terms of cost and space with a single machine, a server. It's easily configurable. If you wanted to do a security exercise, you'd have to like be able to rearrange the computers and set up different network connections, which in physical reality would end up with something kind of like this. But what we can do is actually have a simple configuration file that makes it very, very simple to rearrange the computers and set them up. And then finally, the design is secure and easily sandboxed, so we can protect our local area network and the internet and the students' machines from competing interests. Okay, so just to give you, Zen Worlds' paradigm is that they give each student or group of students a collection of machines that they call a world. This is from some website, but the basic idea is that like a business could put their entire web serving system on a virtual server, virtual only machines. What we would do is, for example, have a lab where we do cross-site scripting. So you have like a web server, a client machine, and an attack platform, 3 machines. And every student gets those identical copies of those 3 machines to work on their own. My work over the summer was to solve some design problems that were kicking around from work I've been doing last year. I wanted to make it as easy to use as possible for faculty and administrators as well as students, so it would be more readily adopted. And I mostly was concerned with writing the middleware, which is software that handles all of the students' interactions with the program and makes the administrator's life easier. I used Zen. This is my virtualization software. It's open source. It's very well tested, very venerable, and fast. It's pretty cool. I used Linux, Debian, and Python was the language that I used to write the scripts in because it's high level but powerful enough to do a lot of sort of cool abstract stuff, but also do system stuff. And then I used a program called PDMenu, which is a simple, small C program that makes graphical looking menus in a terminal for students to use. And this is actually what ours looks like. But so you can do an SSH session into a machine, get this menu, so you'll get one lab out, you can access it and do all this stuff. We'll get to that. Anyway, So how does it work? The administrator makes a single account to put all the files in, the scripts, the config files, and the VM storage files. They're disk images. You see that ING is a disk image, not like a JPEG or something. It looks kind of like this in the very abstract. I'll talk about it more later. But so they make this account, and that's where everything lives. Students access it through a different way. We had to come up with a way to sort of assign unique names to the VM, so we could separate them both in storage and in hypervisor, which was running at the time. So we used a very simple naming scheme of just class, lab, group number, VM number. So yeah, just note. And then our directory structure ends up becoming this, which is actually a working test structure that I have running right now. It looks complicated, but you can see that there are two duplicated directories. So base is what the administrator would create, and then our software copies it for every group, so everyone has their own copy of the world. And then there are a couple of config files. Main.config, they're all very simple. It has a list of the currently running labs, the software uses, so like you know what to load. There are groups, which is the same format as a Unix user group file. Group 1 has 2 people in it. I'm one of them. Group 2, etc., and so forth. The lab file just has metadata used by the naming system, so the name, number, just to say like, okay, this is the lab you're logging into, so some of your code. And the world configuration file, as I showed you guys earlier, is how we configure the actual networking and interaction between machines. It's pretty simple. It mostly just has networking information. I have those there. Disk information, etc., and so forth. So they're all pretty short, pretty simple files. Not really going to go through this, I don't think. The Python code just represents all the different levels of the system of XenLabs using objects and some inheritance is going on. All it needs is to have the lab file be a certain structure which it creates automatically, so you can't really, you could change it and that would break it, but it handles it all for you. And then it just does the rest of the work. And we have some utilities to do work for the administrator and stuff. So for the admins, they can create the configuration files as well as the virtual machines. You can use any standard tool. This is probably like a little bit too far into the specifics, but Dev Bootstrap, bird install, whatever. They're pretty easy to use. So you can create those and then write 3 config files, as I showed you, are pretty simple. And then just add that directory to make a config and run setup, which will create all of your directories and all the links for all the students to access. So you just create, just a couple of files and put it wherever you want it, and put a path name and it does the rest. So that's all the text you would need to create. Admittedly, a very simple world, but it's all very copy and paste after this. The students log in with their own computer name onto the XenLabs server. It gives them PD menu as their shell. This is important because we're giving students root access to machines to do all kinds of security work. It's really important that they can't do whatever they want on the server machine, which they are actually logging into. That could be very bad in terms of like academic honesty or just general mayhem and tomfoolery. So PD menu uses a Python script to dynamically generate the menus. It runs through the config files and says, okay, so you have 2 labs that you're a part of. I'm going to give you access to those. And then it generates the menu file, which is kind of complicated, but it ends up giving them this. So some student logs in and has 3 labs running. For each lab, they can get this access. They can go to the lab and they can connect to any machine. They can manage the machines and they can start them, reboot them, shut them down like you would with an ordinary machine. And then you can snapshot them to save their state. Right now, that just is a very brute force thing, but hopefully we're going to finesse it later. And this is just a final shot of what it looks like at its most basic. This is a test setup that I got working a couple days ago. So as you can see, you would log in to that lab and connect to the first virtual machine. It would give you a port number, which you can then use a VNC client to connect to, and then this gives you a virtual machine. It seems like just any other, like a real physical machine, but you can just, and if I just could do it right now, you can just type root and it logs you in, and you can do whatever you want to that machine. But it's all sitting on the server, and this is all you can access. It's very good. Okay, so conclusions. I'm currently finishing the code, which I hope to be done with very soon, and so I can get some testing in. There are some future features we'd like to implement. The hand-in program right now, there isn't one. If you wanted to grade it, you'd have to go through the directory and look at the files, which isn't that hard to do, but a little obnoxious maybe. And we'd like to be able to do snapshots via CAL, which is copy on write. So the idea is that most students would have basically the same exact disk image. They're going to add a couple program files, maybe modify a few parameters, but out of like a 4 gig disk image, they'll modify like a couple hundred kilobytes usually. So we use copy on write, which is like subversion for a file system basically, and only copies the disk. But as of right now, Zen's support for that is incomplete. The new release does have support, but it's still in beta, so I'm waiting until it gets a little more stable. But hopefully, maybe by the end of the fall, we'll be able to implement that. And that would be really cool because it would make it so much more efficient space-wise. We're having a workshop in Oberlin on August 4th where we'll be demoing the software, showing people how to set it up, and showing an example lab. If you want to come, if you're interested in learning more about the software, you can contact Dan Cooperman. That's his email address. He's my advisor on the project. And he'll also present a paper on this work at a conference called CCSCMW in September. And that's all.
Any questions for the speaker?
So this is going to be implemented in a course? Is that the ultimate?
Yes. Yeah. We're hoping to have it. Well, we're hoping to have it ready for the security course being taught in the spring at Oberlin College, and we're trying to get enough labs together that it'll be like really meaningful for the students to use it for almost all of their labs. Yeah.
Is there an explicit ethics component to the course? Because you're training them to be black hats as well as white hats.
Right. Well, a lot of the motivation behind this project was to let them do that, but in a sandbox setting. We definitely had problems when I was a freshman student with people's projects bringing down our network, and so that won't happen anymore. And they can do a lot more than they could before, which is really cool.
Other questions? Okay. Thanks, Peter.